Good morning. Today I am going to discuss about types of electrochemical corrosion. What is meant by electrochemical corrosion? Electrochemical corrosion occurs in the following two categories. One is when two dissimilar metals are in contact with each other in the presence of electrolyte, or a metal is exposed to varying concentration of the oxygen. Electrochemical corrosion is possible. Then first type, galvanic corrosion. When two dissimilar metals are in contact with each other in the presence of an aqueous solution or moisture, galvanic corrosion occurs. Here, the more active metal with the more negative electrode potential acts as a anode, and the less active metal with less negative electrode potential acts as a cathode. So in this diagram, galvanic corrosion is represented. In the first diagram, zinc iron couple. Zinc is more active, so it acts as a anode. Iron acts as a less active metal, so cathode. So anodic metal undergoes oxidation process, that means corrosion. Second category, iron copper couple. In this diagram, in this representation, iron is more active metal compared to copper. So in this case, iron acts as a anode, copper acts as a cathode. Anodic part always oxidation occurs. So zinc iron couple, in which zinc more active or higher in EMF series, dissolved in preference to iron, less active metal. So zinc acts as a anode and undergoes oxidation process, that means corrosion, and iron acts as a cathode. In the copper iron couple, iron copper couple, in which iron more active when compared to copper, dissolves in preference to copper. Iron acts as a anode and undergoes corrosion process, and copper acts as a cathode. Examples for galvanic corrosion. Steel screw in a brass marine hardware corrodes. This is due to the galvanic corrosion. Iron higher position in electrochemical series becomes anodic part and is attacked and corroded, while brass lower in the electrochemical series acts as a cathodic part and it is not attacked. Then bolt and nut made up of the same metal is preferred. Why? It is preferred in practice because galvanic corrosion is avoided due to the homogeneous metal. Because the main condition for the galvanic corrosion is heterogeneous metal is needed. So no anodic part and cathodic part are preferred in the homogeneous metal surfaces. So galvanic corrosion can be minimized by the following two ways. One is by providing an insulating material between the two metals. Second one, by selecting two metals as close as possible on the EMF series. Second category, first one is galvanic corrosion, second one is differential aeration or concentration cell corrosion. This type of corrosion occurs when a metal is exposed to varying concentration of oxygen or any electrolyte on the surface of the base metal. Metals, example, partially immersed in water or conducting solution called waterline corrosion. If the metal is partially immersed in a conducting solution, the metal part above the solution is more aerated and hence become cathodic. On the other hand, the metal part inside the solution is less aerated and thus become anodic and suffers corrosion. So less anodic part acts as a less aerated anode, corrosion occurs. In this diagram, in the metal rod dipped in the water bodies, so inside the water bodies act as a less aerated part, more corrosion occurs because it acts as a anodic part. More aerated part act as a cathode, so no issues. So at anodic, less aerated part, metal converted into metal ions plus 2 electrons. At cathode, more aerated part, formation of hydroxide ions. So in this, both cathode galvanic corrosion and differential aeration corrosion. First corrosion, galvanic corrosion is possible when the two different metals are needed. One is act as a more active metal, one act as a less aerated and less active metal. That means anodic part and cathodic part. In the case of the electrochemical corrosion, especially differential aeration corrosion, when a single metal exposed to varying concentration of the oxygen. Less aerated, more aerated. Less aerated part acts as a anodic part. act as a anodic part, that means it undergoes corrosion process. More aerated act as a cathodic part, that means cathode, it acts as a cathode, no issues. So these are the types of electrochemical corrosion. One is galvanic and the one is electrochemical corrosion, differential aeration corrosion.